All right, today we're going to dive into something really deep. We're talking about some of the biggest questions in physics. And look, these aren't just little nagging puzzles on a whiteboard. Some physicists are starting to think they're actually huge clues, clues that our entire understanding of the universe, the very picture we have of reality, might just be wrong. So let's go looking for the cracks in the foundation of modern physics.
So let's just start with this one massive question, right? What if? What if everything we've built over the last century, incredible things like relativity, quantum mechanics, what if it's all built on a foundation that's, well, just not stable? That's the mystery we're really digging into today.
The whole idea we're pulling from here is that there are these 5 unavoidable questions. And get this, the argument is that our inability to answer them isn't just because we haven't gotten there yet. No. It might be a sign that something is deeply, fundamentally wrong with the physics we're using right now.
Okay, so let's do this. Let's treat these 5 questions like clues in a detective story. We're going to go through them one by one and see exactly what kind of cracks they show us in our current picture of reality.
So first up, and this one doesn't start with atoms or black holes or any of the usual suspects. Nope, it goes way deeper. It targets the very language physics speaks, mathematics.
Yeah, this is a pretty bold challenge, right? The source is basically saying that the core ideas we take for granted in math, things like a smooth, continuous number line, or even the concept of infinity, are maybe just wrong, that they're flawed approximations of what's really going on.
And this really shows you what's at stake. I mean, think about it. A theory, like general relativity, it assumes that space-time is smooth and continuous, kind of like a ramp. But what if reality at its most basic, fundamental level is more like a staircase, made of tiny, discrete, individual steps? If the math we're using, the ramp math, doesn't actually match the reality it's supposed to describe, well, how stable can that skyscraper of modern physics really be?
All right, on to question number 2. And this one really gets into the difference between simply describing what happens and actually explaining why it happens.
Now, what's so interesting here is the split between mathematics and machinery. Physics has gotten unbelievably good at the math part, right? We have the equations that can predict outcomes with incredible accuracy. But what about the physical mechanism? The actual gears and levers of reality that cause those outcomes to happen?
Yeah, this is a perfect way to think about it. The math, that's the what. It gives us the equation to predict a particle's path. But the machinery, that's the why and the how. It's the physical reason the particle follows that path in the first place. This is a huge pushback against that old shut up and calculate attitude in physics. It's demanding not just a prediction, but a real explanation.
Okay, question 3. This one gives us a really solid, concrete example of this missing machinery, and it focuses on the stuff that makes up, well, everything.
So, fermions. These are the matter particles. We're talking electrons, protons, the stuff that makes up you, me, this desk, everything. And we have these incredible mathematical rules that describe their behavior perfectly. But this question is asking, okay, but what's the physical reason for those rules? And that's the whole point, right? We've got this super powerful math that works, but it's just a description. We know the rule, for example, that 2 electrons can't be in the exact same state at the same time, but we have no physical machinery, no why to explain that rule. And the source really sharpens this point by claiming we're not even really looking for that reason.
All right, number 4. This one takes us right into the heart of Einstein's relativity, and it uncovers a totally mind-bending paradox about how we think about time.
Okay, just think about a photon for a second, a single particle of light. It has a story, right? It's born, it travels across the universe, and then it gets absorbed somewhere else. It clearly goes through a sequence of events. It changes. But from its own perspective, how much time actually passes during that journey?
You can see it right here. The photon has this clear journey. There's a step 1, a step 2, a step 3, a beginning, a middle, an end. It has a history. It definitely experiences change. But, and this is the kicker, according to Einstein's theory of relativity,
0 time passes. For the photon, its entire trip, whether it's across this room or across billions of light years, it's instant. Its birth and its death happen at the exact same moment. So how can something have a whole history of change if absolutely no time has passed for it? That's a huge contradiction right at the core of our best theories.
And that brings us to our 5th and final question. And this one tackles one of the biggest and maybe one of the most embarrassing mysteries in all of cosmology. Okay, so we know the expansion of our universe is speeding up. We've even given a name to the mysterious force pushing everything apart. We call it dark energy. But if you ask a physicist, so what is it really? The honest answer is, we have no idea.
And look, this isn't some small fringe problem. Dark energy makes up almost 70% of everything in the universe. And yet our best explanations for it are, and this is physicists themselves saying this, considered unlikely scenarios. The fact that we can't explain the main ingredient of our own universe, that points to a pretty major breakdown in our cosmic model. So after all that, what do we do with these 5 questions? The source we're looking at says we can't just put them in a folder labeled stuff we don't know yet. We have to see them all together as a collective call to action.
And this is really the main argument. These aren't just 5 separate puzzles to be solved one day. They're 5 different symptoms of the same deep underlying problem. They're like the tip of an iceberg, suggesting that our whole paradigm, our fundamental way of looking at the universe, is just not up to the task anymore.
But you know, when an old way of thinking starts to fail, that's when new ideas start to pop up. The source of these questions doesn't just point out all the problems, it actually proposes a new path forward, a whole new way to model reality.
The alternative that's put forward is something called a 2-level model of reality. Now, we can't get into all the details right now, but the basic idea is that there's a deeper, more fundamental level to reality, that machinery we talked about, and that's what gives rise to the physics we can see and measure. So the call to action is to stop trying to just patch the cracks in the old building and instead start looking at the blueprints for entirely new ones, like this model.
And that's where we're left, with this final massive question. You know, if today's physics really is standing on a flawed foundation, then answering these 5 big questions won't just fill in a few gaps in our knowledge. It could trigger a total paradigm shift, a completely new, maybe even unimaginable understanding of our universe. So, what do you think is waiting for us just beyond our current horizon?